I'm Frederick Marks, a founding member of Anfa and its current CFO, and it is a privilege for me to talk about this next session as a moderator. For those of you who have attended biennial conferences in the past for Anfa or are frequent visitors of our website, you very may know about the Harold Hay Research Grant Program. But for those of you who are not familiar with it, it began in 2012 thanks to an estate gift that was established by the late Harold R. Hay, who was an environmental engineer and a pioneer in the development of solar energy systems. You should also know that this bequest never would have happened had it not been for our current president, Gil Cook, having a long-term relationship with Mr. Hay. And this took place at California Polytechnic State University in San Luis Obispo, and at this time Gil was the director of the Architectural College. I was fortunate when I was an undergraduate school student in architectural school to have taken a master class with Harold Hay. And what I remember most about his lectures was the emphasis and importance on sustainability, something that we almost take for granted now in design and construction. I believe that Harold understood very well in his later years of life that a significant investment in neuroscience research would benefit all of us in the future, whether we be directly or indirectly involved with the building industry. The first award that Anfa made was given 3.5 years ago to the principal investigator, Sergei Gepstein, of the Salk Institute, in collaboration with Alex McDowell, who was at the University of Southern California, and Greg Ling at the University of California, Los Angeles. Sergei, who is now a board member of Anfa, will speak to us later about his original work and what he's done since that time. But before that, we will hear from investigators who have recently won awards. This is in January of this year. One team is working in Israel, and the second one is located in India. As you listen to these reports, I encourage all of you to understand that this is a proof of concept exercise. Our hope is that feasibility will be demonstrated and that research will continue with other support. One final note. Based on the results that are presented this year, the Anfa board will decide what the next Harold Hay grant program will be in terms of solicitation. What I do at this point is ask that you look very carefully for notices that will come in the coming months. And now I'd like to present Mr. Palti from Israel, who will talk about his research on curiosity. Thank you.
Can you hear me? Yeah? Okay, thanks very much for the introduction. And first of all, I just want to say thank you to Anfa for the funds, for the grant, for facilitating this research, and I hope it's going to go in a good direction. So we're a few months into the study, so it's kind of at the beginning, but I'm going to talk a lot more about the methodology and why we chose this methodology, and then present to you some of the findings that we have so far. So I'm Palti, I'm an architect. The team working on the study is myself, Moshe Bar, who is, some of you might know him, he's a world-renowned neuroscientist, and Amir Tal has joined us with some expertise in, I'm not getting my notes here. Just 1 second. Can anyone help me with this one? was working in the morning. Can anyone help with it? Sure. Sorry about this, guys. So, I'll continue speaking until it's fixed. So, the conversation that Moshe Bar and I started having a month ago. Sorry? That's where it was, yeah. I don't know. No, but you see there's no notes at the bottom. Do you remember this morning? So the conversations that Moshe Bar and I have had over the past year have led to one publication that we had published in The Guardian, which was the Manifesto for Conscious Cities. The idea behind Conscious Cities is to ask how can the built environment be responsive to our needs, partly through how it becomes aware. Cheers, thank you. How it becomes aware of our needs, and also how do we include the application of cognitive sciences in architecture and planning. And so we set out to think how this can be done. Starting point for us was that neuroscience cannot design, not by itself. It can't generate space, nor be deterministic about conducting an experience through space. What neuroscience could do, we think, is inform design and help shift the focus of design from efficient to effective. Architecture and design tend to focus on efficiency, partly because the metrics for it are known and accessible, and therefore dictate how design is valued by clients. We rely on metrics such as cost per square meter, or maintenance, or energy use. So here you see the kind of language that architects are used to using, and sorry that it's a bit cut off on the side there. If neuroscience can create new metrics for design, could it then also shift the focus of architecture from efficiency to effectiveness? Will it be possible to value a building in the future for benefits such as improved memory and learning? So why are metrics so important to how we might integrate neuroscience into design? Have a look at this simplified timeline for an architectural project. These are the moments where neuroscience, we think, can step in. Firstly, in furthering the analysis of existing environments to give a background to what we know already, and so inform clients and designers before pen touches paper. Metrics can be used to analyze design options created by architects and inform which designs are working towards the goal of a project. Lastly, metrics can help us feed back into the evidence-based design cycle in post-occupancy. So we proposed an approach to creating metrics for measuring the human experience in the built environment. Metrics that can be used by architects to shift the focus to different qualities of their work. In a way, our project is as much about this methodology as it is about curiosity, in the hope that it is replicable to other components of experience. We began by observing, and this is a very simplified chart, the links between the built environment and the human experience, beginning with the physical space, social situations, and individual perceptions, the types of cognitive processes that occur, and then how they relate to an experience and behavior. From there, in our own research, we decided to do reverse engineering, so we worked backwards. As the title of the project suggests, our focus is curiosity. It has the characteristics of an intrinsic drive and therefore affects much of our behavior, our memory, and opens a cognitive window. Take, for example, a study by Matthias Gruber that showed curiosity arousal improved memory retention, even of information unrelated to stimuli. So what you see on the screen is chronologically what subjects saw in the study of Gruber. What they found is that subjects that were curious towards a trivia answer not only remembered the answer better, but also remembered a visual of a face in between the question and answer, which means that when curiosity is aroused, we tend to absorb a lot more information, not necessarily from a direct source of arousal. So we set out to create a specific situation, first in lab conditions, which will help us focus on the phenomenon. Through our study, we must be we must be able to differentiate curiosity-driven attention from other forms of attention. And with this in mind, we reached a working definition for curiosity: voluntary time on target for the purpose of gathering information. This meant we had to create the conditions where we could observe the intentional allocation of visual attention. So in order to be sure that directed attention we observed is intentional, we devised a task and a method to observe when a subject chooses to divert attention from the task. So I'll first explain what the task is. The subject's task is to respond to a series of letters displayed at the center of the screen, answering to whether they do or do not have rounded qualities. So for an S or C, the subject would have to press right on a keyboard, and for W or T, where it's angled, left on the keyboard. Motivation is encouraged through feedback images for wrong and right answers. In a random order, distractors are displayed around and equidistant from the task. We created 206 individual distractors in 5 sets that appeal to different types of curiosity based on existing literature. Distractors appear at the same time as a letter, and so response time to each letter is then attributed to the distractor which appears. Maybe this graph will help us understand. By comparing response times of different distractors, we look at the largest delta, which differentiates the moments when subjects diverted most and least resources away from the task. So if in the first one, what you saw is one distractor, is this teapot and then this kind of strange American flag, we look at the difference of the response time to the task. So that's answering to whether the letter is rounded or angled. And through this, through the delta created by the response time, we understand how much attention has been diverted away from the task. The graph shown here is from a pilot for the study, showing the spectrum of average response times for each distractor. By creating the conditions by which we can differentiate between more curious and less curious behavior, we can observe how this manifests in eye movement and EEG. Again, it's a bit cut off on the side there. This will be done by comparing average ERP and eye movements in the times correlating to distractors which produce long and short response times. The process, we believe, will help us characterize curiosity, leading to the metrics we seek for design. So back to our process. The focus on behavior led to characterizing the phenomenon through measurables, so that's ERP and eye movements, which in turn lead to design heuristics, and I'll kind of go into what that means, design heuristics. Data that can guide design through site-specific testing or more general guidance. As first presented, we do not believe that neuroscience can be deterministic, so there are ways we think that new metrics will serve design. Again, back to the diagram of where neuroscience can enter design and what this means for an architect. So first of all, if we have the metrics, we can look at existing buildings, try and see what we've learned, what we've done right, what we haven't done right, and therefore feed back into a project initiation or the preparation of the brief. The designer has to do the design, and when they come up with a number of options, metrics can help us choose which design works best for the project goals. And then again, in post-occupancy, these metrics can be used to evaluate whether a design has been successful or not in the goals. These are the 3 things that I've just mentioned. So informing designers of new findings that can augment the design process. Once metrics are in place, they can be used to compare design options through running subjects of simulations, and this can be done in VR, obviously. And then the use of same metrics can aid post-occupancy. As was mentioned before, this is a kind of proof of concept of what we're trying to do. So once we have got these metrics, the idea is that we go for these next goals. So some of the goals for the future of the study is where you'll see an obvious link to whether we understand neuroscience fitting into the design process, linking curiosity, first of all, to learning, which is one of the reasons why we might use curiosity metrics to design learning environments, for example. Using metrics created by study to evaluate existing buildings. And after these metrics are ready, developing the platform for designers to use findings for future research. So we don't, obviously, one of the goals of Anfa and this conference is how do we bridge between the two professions of neuroscience and architecture, and one of this is to actually develop the platform so that architects are not intimidated by this kind of research and are able to use metrics and integrate it into the workflow. So we look forward to continuing this research and publishing the results next year, and maybe in the next conference we'll be talking about it. In the meantime, we're also working to further this field of research alongside Anfa. So if any of you have heard of Conscious Cities, we had the first Conscious Cities conference, which was about architecture and neuroscience last year in London. There's going to be the next one also in London in 2017, and there's a website with some of the publications available on there. You can look out for any statements for when the conference is happening next year. And that's it. Thanks a lot for listening, guys.